When we say the universe contains 2 trillion galaxies, the sentence slips off the tongue so easily that it sounds almost polite, like announcing the number of passengers on a very large cruise ship. 2 trillion, the phrase feels tidy, almost manageable, as if we could print it on a sticker and slap it onto a poster. In reality, the moment you try to hold that number in your mind with any seriousness, something inside the brain makes a faint popping sound and quietly gives up. It is not a number that belongs to human experience. It belongs to something older, colder, and far less considerate of our emotional comfort. Let us begin with the observable universe, the only part we can ever hope to speak about with even a trace of authority. It is not the entire universe. Nobody knows how big the whole thing is, and it may well be infinite, but only the sphere centered on Earth out to the farthest distance from which light has had time to reach us in 13.8 billion years. That sphere is roughly 93 billion light years in diameter, because space itself has been expanding while the light was traveling. Inside that volume, the best current estimates, drawn from a decade of Hubble deep fields, Planck satellite data, and the first flood of images from the James Webb Space Telescope, place the total galaxy count at approximately 2 trillion. Sometimes the figure is quoted as 1.5 trillion, sometimes as 2.5 trillion, but the order of magnitude is no longer in dispute. 2 trillion is now the conservative middle ground. To arrive at that number, astronomers did not count galaxies one by one, the way a child counts marbles. That would be impossible. Instead, they pointed telescopes at tiny patches of sky no larger than the eye of a needle held at arm's length, and counted everything visible in those patches. In the famous Hubble ultra-deep field, taken in 2003-2004, a region 1/10th the diameter of the full moon revealed about 10,000 galaxies. The exposure totaled nearly 1,000,000 seconds, almost 11 straight days of staring at what had always looked, to the naked eye, like pure emptiness. When the image was released, people joked that astronomers had found the only blank spot in the heavens and discovered it was packed wall-to-wall with cities of stars. Later, the Hubble Extreme Deep Field pushed even deeper and found still more. Then came James Webb, with its infrared eyes that can pierce the dust that blocks visible light, and suddenly galaxies that had been hidden since the universe was a few 100 million years old began popping into view like cities turning on their lights at dusk. The early results were so startling that one prominent cosmologist visiting the Space Telescope Science Institute saw the first processed images and reportedly whispered an expletive so creatively astronomical that his colleagues are still trying to get it published as a technical term. The method is statistical extrapolation. Count the galaxies in a representative sliver, measure how many square degrees that sliver occupies out of the entire celestial sphere, about 41,253 square degrees in total, and multiply. Adjust for the fact that fainter galaxies become harder to see at greater distances. Correct for the ones hidden behind foreground dust or merged into single pixels. Factor in the new populations Webb is revealing from the cosmic dawn, and the answer comes out around 2 trillion, give or take a few 100 billion. The uncertainty is now smaller than the difference between 2 trillion and 10 trillion, which means, in a delightful twist of cosmic accounting, we actually know the number better, percentage-wise, than we know the population of several medium-sized countries on Earth. But numbers alone do not convey the violence of the revelation. 2 trillion is not twice a trillion, it is 2 million times a million. If you decided, in a fit of monastic dedication, to spend 1 second contemplating each galaxy individually, and you somehow managed to stay awake and focus 24 hours a day, it would still take you more than 63,000 years to finish the job. By the time you reach the final galaxy, the light you had been looking at from the first one would have left when the universe was less than a tenth its current age, and every human being who ever lived would have been dead for 60 millennia. Each of those 2 trillion galaxies is itself an ecosystem of staggering complexity. The Milky Way, which we once thought was unusually large, is now understood to be merely above average. We contain roughly 300 billion stars, possibly 400 billion if you believe the higher estimates that include the faint red dwarfs we keep rediscovering. Many galaxies dwarf us. The giant ellipticals like M87 in the Virgo cluster contain trillions of stars apiece. Others are puny, the so-called ultrafaint dwarfs orbiting our own galaxy, with only a few million stars each, yet even those are counted as full members of the 2 trillion club. If you average it out, and averaging is a sin here, but let us commit it for the sake of sanity, astronomers often use a figure of 100 to 300 billion stars per galaxy as a reasonable mean for current census. Take the middle 200 billion. Multiply by 2 trillion galaxies and you arrive at 400 sextillion stars, though many recent papers prefer a more conservative 100 billion average, yielding the 200 sextillion that sometimes appears in public lectures. Either way, the difference between 200 and 400 sextillion is itself larger than the total number of stars we thought existed in the entire universe when I was in elementary school. To feel that number, forget scientific notation for a moment. Write it out the long way, the way Victorian astronomers used to do when they wanted to punish their typesetters, that is 200,000 trillion. Or, if you prefer, 200 million billion, count the zeros, 20, 2 of them trailing behind the 2 like a bridal train made of nothingness. Comparisons to grains of sand have become cliché, but they remain the least inadequate metaphor we have. All the beaches on Earth, all the deserts, every grain visible under every microscope on every dune and shoreline, total perhaps 1018 or 1019 grains if you are generous. The stars outnumber those grains by a factor of at least 10,000. If every star were a grain of sand, the Sahara would be a thimbleful, and the Earth itself would disappear beneath dunes miles deep, with enough left over to bury every planet we have ever imagined. Real or fictional, 100 times each. Another way, suppose you could compress the entire observable universe into something the size of Texas. Even then, the average density of galaxies would be 1 per cubic centimeter. Texas would contain 2 trillion of them, each a swirling disk or ellipsoid of 100 billion suns, all packed so tightly that their outer halos would overlap like smoke rings in a crowded bar. And Texas is not even a particularly large state, or think in terms of time. The universe has been around for 13.8 billion years, which is 35 times 1017 seconds. There are roughly the same number of seconds in 13.8 billion years as there are stars in a single large galaxy. That means, in the time it has taken the universe to age from the Big Bang to now, it has created enough stars to give every single second of cosmic history its own private galaxy with 100 billion suns left over as change. These are not idle parlor tricks. They are attempts, clumsy but necessary, to force the nervous system to register a quantity that evolution never prepared us to grasp. Our brains evolved to track maybe 100 individuals in a social group, to estimate whether 20 antelope are enough for the tribe, to feel rich if we owned 1,000 beads. 2 trillion is so far outside that design specification that the mind treats it the way the eye treats a blinding light. It squints, it looks away, it substitutes a symbol for the reality because the reality is neurologically indigestible. Yet the astronomers who work with these numbers every day do not walk around in a permanent state of stunned silence. They develop a kind of affectionate numbness. They speak of the galaxy population, the way city planners speak of traffic flow. They draw plots on logarithmic axes where a factor of 1,000,000 is a single tick mark. They name the problem of counting 2 trillion objects the pencil beam instability, and then go to lunch. This is not callousness, it is a survival mechanism. If you let yourself feel the full weight of the number every time you said it, you would never get any work done. You would just sit in the corner whispering 2 trillion over and over until security escorted you gently from the building. Even the professionals, though, have moments when the mask slips. I once watched a room full of hardened cosmologists fall silent when the first James Webb Deep Field was projected on screen. The image was colorful, almost garish, because infrared light had been translated into visible wavelengths, and the galaxies looked like jewels spilled across black satin. Someone in the back did the calculation aloud. The patch shown was less than 1/10,000,000th of the sky, and it already contained tens of thousands of galaxies, many of them older than any we had ever seen before. You could feel the room recalibrating its sense of reality, the way a tightrope walker feels the rope go slack and then taut again under shifting weight. 2 trillion is not the final number, it is only the current lower bound for the observable universe. As telescopes improve, as algorithms get better at picking individual galaxies out of crowded fields, as we learn to see farther into the epoch when the very first galaxies were assembling themselves from collapsing clouds of primordial hydrogen, the count will keep rising. Some theorists argue that if we ever manage to observe out to the true horizon of the cosmic light, travel distance, accounting for the most distant possible photons that could still reach us after scattering through the reionization era, the total might climb toward 10 trillion or more. For now, 2 trillion is the number we have, the number we live with, the number that has quietly demolished every previous intuition about our place in the scheme of things. And still, when all the data are folded together, when the error bars are argued down to their narrowest, when the referees have signed off and the press release is drafted, the universe turns out to contain 2 million times more galaxies than the number of people who have ever lived on Earth. 2 million times more galaxies than there are books in every library, 2 million times more galaxies than there are grains of rice harvested in a year, 2 million times more galaxies than there are cells in a human brain. That is the first part of the mind, bending truth. Not that the universe is big, we suspected that, but that it is big in a way that makes bigness itself seem quaint. The word astronomical used to be the largest hyperbole we had. Now even astronomical is too small. We need a new word, one that means so large that the astonishment circuit in the brain fuses shut and has to be replaced. Until Merriam-Webster catches up, 2 trillion will have to do. And that is only the first tremor in the earthquake that is coming. Because once you have swallowed the fact of 2 trillion galaxies, the universe leans in close, smiles like a cat that has been watching you struggle with the can opener, and whispers the next part. Every single one of those galaxies is real, right now, happening in places so remote that their existence can never affect us in any physical way, ever. They are not possibilities, they are not approximations. They are there, burning, colliding, forming stars, exploding, living out their multi-billion-year biographies in perfect indifference to whether we ever manage to count them correctly. 2 trillion separate cosmic stories, each as rich as our own, playing out this instant on stages we will never visit, under skies we will never see. And still the universe found the time, the space, and the raw material to assemble one tiny world where a thin film of water and air allowed creatures made of stuff to stand up, look out, and eventually, after a few 100,000 years of arguing about it, figure out that the answer is 2 trillion. That is the scale we are asked to live with now, not just large, not just huge, but a scale so profane in its generosity that the only sane response is to laugh or cry or both at once, while the night sky watches in polite silence and waits to see what we will do with information. If you have ever tried to picture a trillion of anything, you already know the moment when the mind quietly surrenders. A million seconds is about 11.5 days. A billion seconds is nearly 32 years. A trillion seconds is 31,688 years, long enough for anatomically modern humans to walk out of Africa, invent agriculture, build the pyramids, burn half the Library of Alexandria, fight 2 world wars, and still have 12,000 years left over to argue about politics on the internet. That is 1 trillion. 2 trillion galaxies means we must do that trick twice, and then multiply the vertigo by the fact that each galaxy is itself a riot of hundreds of billions of suns. The brain, faced with this, performs a neat little sleight of hand. It replaces the actual number with a cartoon symbol, a kind of mental shrug that says really big, and hopes nobody will notice the substitution. But the numbers are not content to stay politely abstract. They keep trying to crawl off the page and invade ordinary life, like ants escaping a jar. So let us invite them in, deliberately and mercilessly, until the familiar world buckles under their weight. Start with something you can hold in your hand, a single grain of sand, fine beach sand, the kind that slips between your toes at the end of a summer day. 1 grain is roughly half a millimeter across, maybe a quarter of a milligram. Now walk the beaches of the world. All of them. The Caribbean, the Maldives, Copacabana, the endless winds, sculpted dunes of the Sahara, the black volcanic sands of Iceland, the pink shores of Bermuda, the glowing carbonate beaches of the South Pacific, where the sand is made of parrotfish poop. Yes, really, collect every grain. Then add the Gobi, the Kalahari, the Simpson Desert, the empty quarter, every dry lake bed and river delta, every sandbox and hourglass and concrete mixer on Earth. Keep going until you have scraped the planet clean of loose silicate grains, finer than gravel. How many do you have? The most generous estimates, ones that include desert dust and seabed sediment, reach somewhere around 10 to 10 grains, possibly as high as 10 if you cheat and count microscopic quartz particles suspended in the atmosphere. Let us be extravagantly charitable and call it a quintillion grains. 10. That is every imaginable beach, every desert, every grain that has ever stuck to a wet foot or been blown into the eyes of a camel. 1 quintillion grains. The observable universe contains at least 200 sextillion stars, 2 times 10 to 3. That means there are at least 200,000 times more stars than there are grains of sand in the most feverish, planet-wide sand collection fantasy you can devise. 200,000 times more. If you decided to give every single grain of sand on Earth its own private star to look after, you would still have enough stars left over to hand out another 199,999 complete sets to equally obsessive friends. But sand is too gentle. Let us try something more violent. Water. The Pacific Ocean alone contains roughly 187 quintillion gallons of water. 187 times 10^2. That is already more volume than any human mind can comfortably hold. Yet if every gallon of water in every ocean on Earth were a star, the seas would still fall short by 3 orders of magnitude. You would need to drain 1,000 Earths of their oceans, stack the water molecules into an impossible tower, and even then you would barely have enough to account for the stars in a single large cluster of galaxies, let alone 2 trillion of them, or consider atoms. A single human body contains roughly 7 times 10^2 atoms, 7 octillion, give or take a few billion trillion. That sounds enormous until you realize that the number of stars in the observable universe is about 30 times larger than the number of atoms in every human body that has ever lived or ever will live. If every atom in every person who ever walked the earth were promoted to the rank of star, the universe would still have 29 surplus copies of that entire population burning away in splendid isolation. Time fares no better. There are about 4 times 10 seconds in 8 billion years. That is the entire lifespan of the universe so far, carved into the smallest slices we normally use for everyday timing. There is seconds since the ANG. In other words, if a new star had ignited somewhere in the cosmos every single second since the universe began, the universe would still be 499 complete sets of itself short of the current stellar inventory. Money collapses even faster. The entire global economy, every dollar, euro, yen, bitcoin, and cowrie shell, amounts to perhaps $100 trillion on a generous day. That is 10. You would need 2 million entire world economies running simultaneously to buy one star apiece at $1 each, and even then you would cover only the stars in the local group of galaxies. The rest of the universe would remain insolently unbought, laughing at our financial system from distances that make compound interest look like a childish game. Cells fare no better. The human brain contains roughly 86 billion neurons. If every neuron in every brain that has ever existed were given its own private galaxy containing 100 billion stars each, the resulting total would still fall short of the observable universe by a factor of several hundred. Your thoughts, literally every idea, memory, and random earworm you have ever had, are outnumbered hundreds of times over by entire galaxies. Even the most grandiose human artifacts are humiliated. The Great Wall of China is about 21,000 kilometers long. If you laid 21,000 kilometer walls end to end for every star in the Milky Way alone, you could wrap that chain around the Earth's equator 10 billion times. Do it again for every galaxy in the Virgo supercluster, and the wall would reach the moon and back every second for the entire age of the planet. Keep going for 2 trillion galaxies, and the resulting wall would loop between here and the Andromeda galaxy so many times that the light from one end would not yet have reached the other end by the time the sun burns out. Computers try to help us, but they choke too. The fastest supercomputers today can perform about 10 floating point operations per second. That is a quintillion calculations, a billion. Impressive, until you realize that if every such supercomputer that will ever be built ran nonstop from the Big Bang until the heat death of the universe, the total number of calculations they could perform would still fall short, by many orders of magnitude, of the number of stars that exist right now. Computation itself is dwarfed. Distance, the classic refuge of the overwhelmed imagination, also fails. The observable universe is 93 billion light years across, which already feels obscene. Yet if you shrank the entire observable universe down until it was the size of a grain of sand, half a millimeter, then the average distance between stars within that shrunken cosmos would be roughly the width of an atom. Galaxies would be little more than dense knots in a foam of nuclear scale separations. 2 trillion galaxies would fit, with room to spare, inside the period at the end of this sentence. Even the act of writing these comparisons begins to feel comically inadequate, like trying to bail out the Titanic with a teaspoon. Every metaphor we reach for sand, water, atoms, seconds, dollars, neurons is itself so vast that we normally treat it as a symbol for incomprehensibility, yet each is left panting in the dust by the stellar census. The usual hierarchy of scale collapses. Things we thought were practically infinite turn out to be rounding errors on a cosmic balance sheet. This is where the intuition breaking happens in earnest. It is not simply that the universe is large, it is that it is large in a way that makes every previous category of largeness look like a polite fiction. Evolution tuned us to feel awe at a herd of 10,000 antelope thundering across the savannah, or at a night sky containing a few thousand visible stars. Those were survival, relevant quantities. 2 trillion galaxies, 200 sextillion stars is not survival relevant. It is not even comprehension relevant. It is a quantity that exists purely to remind the mind of its own finitude, the way a desert reminds a traveler that thirst has an absolute limit. And yet, paradoxically, the very breakdown of intuition is what makes the number beautiful. The moment the brain's scaling machinery throws up its hands and says, "I quit," something else opens, an almost physical sensation of vertigo, like stepping off a cliff and discovering you can breathe in free fall. The usual filters fall away. You are no longer comparing the universe to beaches or bank accounts. You are simply in the presence of something that refuses to be compared. The number stops being a quantity and becomes a kind of silent thunder. Children sometimes grasp this faster than adults. Give a 6-year-old the fact that there are more stars than grains of sand, and they do not try to rescue the situation with metaphors. They simply nod why, died, and say whoa. The adult mind, trained to file everything under manageable, spends years learning that same whoa, only with more profanity and existential dread. So when we say the numbers break human intuition, what we really mean is that they break the illusion that intuition is the final authority. They force a surrender that feels, at first, like humiliation, and then, almost immediately afterward, like liberation. The universe is not required to be imaginable. It is allowed to be itself wasteful, extravagant, obscene in its abundance, while our poor primate brains stagger around the edges trying to stuff it into familiar boxes. The boxes shatter, the fragments glitter on the floor, and for one crystalline moment we see clearly the cosmos was never playing by the rules we assumed were universal. That is the second part of the mind bending truth. The first part was the raw count, 2 trillion galaxies, 200 sextillion stars. The second part is what happens inside a human skull when it tries and gloriously fails to drink from that fire hose. The failure itself becomes the revelation. The numbers do not just exceed our grasp, they reach down and pry our fingers loose from the illusion that grasping was ever the point. And once that happens, the universe, with its 200,000-fold surplus of stars over every grain of sand on Earth, stops feeling like a threat to meaning and starts feeling like the most extravagant love letter ever written, signed with light from before mammals had bones, addressed simply, "To whom it may concern, keep looking up." Stand outside on a clear night, far from city lights, and let your eyes adjust. The sky darkens, layer by layer, until the Milky Way appears as a faint river of milk across the dome. You see a few thousand individual stars, maybe 10,000 if the air is perfect. That feels like a lot. It feels, in fact, like the entire contents of the universe, because every one of those points of light belongs to our own galaxy, the one we used to call the universe, with a capital U. Now tilt an imaginary telescope toward any patch of that sky that looks completely black, a patch no wider than a grain of rice held at arm's length. Leave the shutter open for hundreds of hours. What you thought was empty is not empty. It is crammed with galaxies, thousands of them, tens of thousands, each one an entire city of stars, each one so far away that the photons now kissing the mirror of your telescope began that journey when the sun did not yet exist. That is the first shock. The second, deeper shock is this: those photons are not simply old, they are fossils. They are living relics of a universe that no longer exists in the form you are seeing. When you look at a galaxy 2 billion light years away, you are not looking across space. You are looking back into time, exactly 2 billion years into the past. The galaxy you see may have already collided with another, been torn apart, reassembled, or quietly starved to death long ago. Its stars may have burned out, its black hole grown fat and silent. What reaches your retina tonight is the ghost of a metropolis that flourished when Earth was still ruled by microscopic algae, and the continents were arranged in shapes no human will ever walk. The light left home before trilobites, before flowers, before mammals, before anything with eyes existed to notice it was leaving. Go farther, look at the famous Hubble Ultra Deep Field, that postage stamp of darkness, photographed for 11 straight days. The most distant galaxies in that image are 13 billion light years away. Their light set out when the universe was only 400 million years old, a reckless, unruly toddler still glowing orange from the Big Bang. The hydrogen atoms that would one day become you and me were still scattered in a hot fog. There were no stars yet, no planets, no chemistry complex enough to dream of life. Then gravity began to win its slow war against chaos, and the first generation of galaxies, ignited like matches, struck in a dark room. What you are seeing in those smudges of redshifted light are the very first matches. The universe was learning how to make light that was not the leftover glow of creation, but the deliberate fire of nuclear fusion inside newborn suns. Those galaxies are the universe's baby pictures, and we are holding them in our hands. James Webb has pushed the frontier even further back. In 2022 and 2023, it began returning portraits of galaxies that formed only 200 or 300 million years after the Big Bang. Some of them are surprisingly bright, surprisingly massive, surprisingly mature for their age. Cosmologists expected to find tiny, feeble sparks. Instead, they found roaring furnaces already assembling hundreds of millions of solar masses of stars. The light from those objects has been traveling for 13.5 billion years. It has crossed a universe that was expanding so fast that space itself stretched the wavelengths from ultraviolet to infrared, turning the fierce blue-white blaze of youth into the sullen red of extreme old age. To see them at all, we had to build a telescope the size of a tennis court, plate it with gold, cool it to within a few degrees of absolute zero, and launch it 1,000,000 miles from Earth so that heat of our own planet would not drown the whisper from the cosmic dawn. Every photon that finally lands on Webb's detectors has survived an obstacle course that would humble any Odysseus. It was born in the core of a star that died before Earth existed. It escaped the gravitational pull of its home galaxy. It threaded its way through clouds of dust and gas that could have absorbed it forever. It traveled across expanding space that stretched it like taffy. It dodged the glowing fog of the reionization era when the first stars were blasting ultraviolet light into the neutral hydrogen that still filled the universe, turning the fog into a transparent plasma. It slipped past foreground galaxies whose gravity could have bent its path into oblivion. And after 13 billion years of perfect cosmic billiards, it arrived exactly here, exactly now, to be caught by a handful of human beings who evolved on a wet rock precisely because that light, and billions of other journeys like it, happened to warm a cloud of gas at the right moment 4.5 billion years ago. This is why astronomers speak of looking back in time with a straight face. It is not a metaphor. It is literal. The farther out we look, the deeper into the past we see, until the most distant observable galaxies mark the edge of what physicists call the surface of last scattering. For starlight, the moment when the universe finally became transparent enough for light from the earliest stars to travel freely. Beyond that lies only the glow of the Big Bang itself, the cosmic microwave background, a wall of light 380 zeros, 0 years after t equals 0. Everything we see in optical or infrared telescopes is a time machine pointed outward. Stand on a hill at 2 a.m. with a small telescope and find the Andromeda galaxy. It looks like a faint, fuzzy patch. You are seeing it as it was too, 5 million years ago, when our ancestors were still using stone hand, axes, and fire was a new technology. Wave at it if you like. The hominins who could have waved back are long extinct, and the light from your wave will not arrive there for another 5 million years, by which time whatever descends from us will probably not have hands. Go to a major observatory and ask to look at the GNZ 11, currently the record holder for most distant confirmed galaxy. Its light left home 46 billion years ago. When it began its journey, the universe was only 320 million years old, less than 3% of its present age. The Milky Way did not exist, the sun did not exist. The heavy elements that make up your blood and bones were still locked inside the cores of stars that had not yet formed. You are looking at a time before carbon, before oxygen, before the chemistry of life was even possible in bulk. The galaxy you see is running on raw hydrogen and helium, fusing the first metals in frantic bursts of population Roman 3 stars that lived fast and died spectacularly, seeding the cosmos with the raw material for everything that came later, including the calcium in your teeth and the iron in your blood. Every deep field image is therefore a kind of archaeological dig through time. The foreground is littered with relatively nearby galaxies, mere hundreds of millions of years old in light, travel terms, bright and well-defined. Behind them lie galaxies from 1 billion years ago, then 2 billion, then 5, then 10. The farther back you go, the smaller and bluer the galaxies become, because the universe itself was smaller and denser, and star formation was more violent. At the very limit, the galaxies dissolve into red smudges no larger than a few pixels across, yet each smudge is an entire ecosystem of perhaps 1 billion stars. The image becomes a layered cake of cosmic history, with the present moment only the thin frosting on top. This is the part that quietly unravels people who spend too much time staring at these pictures. You realize that the night sky is not a dome of simultaneous events. It is a museum where every object is exhibited at the age it was when its light left home. The moon is 3 seconds old in the sky. The sun is 8 minutes old. Jupiter is 40 minutes old. The Pleiades are 400 years old. Shakespeare could have seen them at the same age we do. Orion's brightest stars are 1,000 years old, still shining with the light that left before the Norman conquest. Andromeda is 5 million years old. When you look across a deep field, you are standing in a single moment now, while simultaneously watching billions of different nows. That happened long ago and far away. The sky is a collage of expired presents. There is a photograph from the Hubble E Extreme Deep Field that contains a single tiny red dot circled by astronomers. It is a galaxy called UDFH 39,546,284, later surpassed, but still beloved. When Hubble first saw it in 2011, its light was calculated to have traveled 2 billion years. That placed its birth only 480 million years after the Big Bang. The paper announcing it caused grown cosmologists to swear in public. The galaxy should not have been visible at all. It was too far, too faint, too early, yet there it sat, defiant, a ruby splinter in the dark. Follow-up attempts with better instruments eventually demoted it slightly in distance, but dozens of others have since taken its place. Webb is now finding hundreds of candidates from even earlier epochs, some possibly only 200 million years after the Big Bang. The universe, it turns out, got busy making galaxies almost as soon as physics allowed it to. This changes everything. For decades, we imagined a slow, stately buildup, darkness for hundreds of millions of years, then a few tentative sparks, then a gradual brightening. Instead, we find a universe that could not wait to light itself up. Galaxies were assembling themselves with almost indecent haste, converting primordial gas into stars at rates 10 or 100 times higher than today. The early cosmos was a forge, not a nursery. And every photon that escaped those forges has been racing toward us ever since, across an expanding void that tried to dilute and redshift it into invisibility. The fact that even one of those photons survived to tell the tale is a miracle of improbable precision. When you finally close the observatory door at dawn and step back into a world of coffee and traffic and mortgage payments, the disorientation lingers. You have spent the night walking through graveyards of time. Every faint glow you saw was a civilization of stars that rose, flourished, and in most cases died before Earth was born. The present universe, the one we live in, is built on their corpses. The carbon in your wedding ring, the oxygen in the breath you just took, the calcium in the bones that carried you down the mountain, all of it was cooked inside stars that lived in galaxies whose light is only now washing over a planet that did not exist when those stars were alive. We are not just in the universe. We are later, arriving epilogues written in the margins of a story that was already ancient when our chapter began. The night sky is not a roof, it is a window into the past so deep that the present moment feels like a thin, fragile skin stretched over an abyss of expired epochs. And still somehow that abyss sent us exactly enough light, at exactly the right wavelengths, arriving at exactly the right time, to let a thin film of water, breathing primates on one moist planet, figure out that the past is still speaking, if only we build machines sensitive enough to hear its whisper. That is the third mind, bending truth. The deeper we look into space, the further we see into time, until the two become the same thing. The universe is not merely large, it is old in a way that folds distance and history into a single, seamless fabric. And every photon now striking Earth is a refugee from a moment that no longer exists anywhere else, except in the trembling excitement of a creature that evolved eyes precisely so it could receive these ancient messages and feel, for one brief cosmic instant, less alone. The first is the Hubble E Extreme Deep Field, a pinpoint of sky smaller than the eye of a needle, stared at for weeks until 10,000 galaxies swam up out of the dark. Swirls, spirals, red smudges, blue starburst knots, all of them entire cities of hundreds of billions of suns, all of them so distant that their light has been en route for 10, 11, 12, 13 billion years. In the bottom right corner, if you know where to look, there is a single pixel that flickers with the combined glow of a galaxy that existed when the universe was less than 400 million years old. That one pixel outweighs, in raw mass and energy, every human who has ever lived. The second photograph is simpler. It is you holding a coffee cup, squinting at your phone, hair unbrushed, maybe 35 kilos of carbon, 6 liters of water, a few grams of iron in your blood, a skull full of 86 billion neurons firing in patterns that feel like love, dread, hunger, and the memory of last Tuesday's rain. The entire photograph fits on a 5, megabyte file. If you printed it at postcard size, the ink would contain more atoms than there are people on Earth. Now place the two images next to each other and try, really try, to hold both realities in your mind at the same time. On the left, 2 trillion galaxies, 200 sextillion stars, a volume of space so large that light itself grows old and dies before crossing it. On the right, one primate, 70 kilograms, lifespan roughly 80 trips around the sun, a thin film of biology clinging to the crust of an average rocky planet, orbiting an average star in an average galaxy. The ratio between the two is so obscene that the word ratio itself feels embarrassed to be used. The universe contains roughly 10 cubic meters of space. You occupy about 0.07 cubic meters. That means the universe is 10 times larger than you in volume alone, and that is before we start counting the stars, black holes, nebulae, dark matter halos, and the sheer extravagance of having 2 trillion separate gravitational empires when one would have been perfectly sufficient for any reasonable purpose. And yet, out of that entire riot of excess, the only place we know for certain that a nervous system capable of noticing the excess has appeared is inside that 1.4 kilogram lump of wet electricity balanced on your shoulders. The same cosmos that scattered 200 sextillion suns like glitter on a ballroom floor also waited 4 billion years for a tide pool to figure out photosynthesis, another half billion for something to crawl onto land, 65 million more for mammals to take over after the dinosaurs politely excused themselves, and then, in the last blink of cosmic time, 200,000 years, produced a species that can look at the Hubble image and feel its chest tighten with something too large for the word awe. That is the contrast that breaks people open. It is not merely that the universe is big and we are small. That would be banal. Planets are big, bacteria are small, nobody writes poetry about it. The insane part is the precision and the patience required to go from the Big Bang to a creature that can experience heartbreak. The universe did not need 2 trillion galaxies to make one planet with people on it. It could have managed with 1,000 galaxies. Or one, or a single globular cluster of 1,000,000 stars, or frankly, with no stars at all, some kind of exotic quantum fluctuation civilization living in the dark between protons. Any of those options would have been infinitely cheaper in terms of matter, energy, and computational complexity. Instead, the cosmos went berserk. It overbuilt reality by a factor of 1 billion, then waited 13.8 billion years, fine-tuning expansion rates to 1 part in 10 so that galaxies could form at all, letting 99% of its volume remain sterile vacuum, just to guarantee that one mediocre G-type star in one spiral arm of one unremarkable galaxy would have a rocky planet at exactly the right distance with exactly right magnetic field and exactly the right moon to stabilize its tilt, and exactly the right bombardment of comets to deliver water, and exactly the right sequence of mass extinctions to clear the stage for mammals, and exactly the right amount of time for a thin layer of neurons to wire themselves into a mind that can ask, "Are we alone?" while staring at a deep field image and feeling tears rise for reasons it cannot fully articulate. That is not efficiency. That is obsession. Imagine an artist who wants to paint a single red rose. Instead of buying one canvas, she buys 2 trillion canvases, stacks them to the edge of the observable universe, spends 13.8 billion years mixing pigments, and then, on one tiny corner of one overlooked canvas, finally paints the rose so delicately that it can look back at the mountain of blank canvases and feel wonder. That is what the universe did. The rose is us. Every atom in your body heavier than helium was forged in the cores of stars that lived and died before the sun was born. The calcium in your bones came from a supernova that exploded 5 billion years ago in a galaxy that no longer exists in the form you would recognize. The oxygen in your lungs was spat out by a red giant that puffed its outer layers into the void when Earth was still a molten hell. The iron in your blood condensed out of a neutron star collision whose gravitational waves rippled past Earth in 2017 and were detected by LIGO while you were probably stuck in traffic. You are not just made of star stuff, as Sagan loved to say. You are made of the ashes of galaxies that no longer exist, galaxies whose light is only now reaching us, galaxies that sacrifice themselves so completely that the only evidence they ever lived is the fact that you can stand upright and feel lonely on Tuesday evenings, and still the universe kept going. It did not stop at enough carbon for one planet. It made 200 sextillion suns, most of them sterile, most of them surrounded by worlds that will never know life, just to be absolutely, extravagantly, stupidly sure that somewhere, somehow, the trick would work at least once. It is like buying 2 trillion lottery tickets just to guarantee that one of them wins the biological jackpot. Except the jackpot is not money. It is the ability to feel the wind on your face and know, with a certainty that hurts, that you will die, and still decide to plant a tree whose shade you will never sit under. That is the part that makes grown astronomers cry in planetarium bathrooms, not the size itself, they are used to the size. It is the realization that the size was not an accident. The universe could have been smaller and still produced consciousness. It could have been vastly smaller, instead it chose, if chose. Is even the right word to be this large, this wasteful, this indifferent to efficiency, as if the only thing that mattered was making absolutely certain that somewhere in the whole ridiculous expanse, a thin layer of water and salt would learn how to look back and say thank you. The contrast is so extreme that it flips the usual existential script. Most people assume cosmic scale leads to despair. We are insignificant, therefore life is meaningless. But the deeper you go into the numbers, the more the opposite feels true. Insignificance is what you get when the universe is exactly the size required to produce you and nothing more. What we actually have is a universe that is insanely, grotesquely, gloriously larger than it needed to be larger by a factor that makes the word larger sound quaint. That excess is not a threat to meaning, it is the only thing that makes meaning possible at all. If the universe were merely big enough, we would be an optimization, a clever hack, a minimal solution. Instead, we are an afterthought written in the margin of a needlessly enormous book. And afterthoughts, by their very nature, are miracles. There is a moment in every clear night when this lands physically. You are lying on your back, the ground cold against your shoulder blades, the Milky Way a frozen explosion overhead. You have just spent 20 minutes trying to wrap your head around 2 trillion galaxies, and the numbers have finally defeated you. Your mind is a smoking ruin, then a meteor streaks across the sky, just a grain of sand burning up at the edge of the atmosphere, and something in your chest cracks open. The feeling is not smallness, it is the opposite. It is the sudden, vertiginous realization that the universe went to all this trouble, all of it, the whole absurd, over-engineered, 10-cubic meter trouble, just to arrange one moment in which a fragile bag of water on a wet rock could feel its heart beat faster because a pretty light scratched a line across the dark. That is the insane contrast, not big vs. small, waste vs. precision, extravagance vs. necessity. The universe spent 8 billion years and 2 trillion galaxies learning how to build a single creature that can be moved by beauty. And then it built 7 billion more, just in case the first batch missed the point. So when people say the universe is too big and we are too small, they have the polarity backward. The universe is not big in spite of us, it is big because of us. It inflated itself to grotesque size the way a novelist writes 2,000 pages of backstory just to justify one perfect sentence spoken on page 1,847. The 2 trillion galaxies are not the foreground. They are the scaffolding erected so that one fleeting consciousness could stand on a hill somewhere, look up, and whisper, "Holy shit, it's beautiful," before the scaffolding is torn down forever. That is the fourth mind, bending truth. The same cosmos that contains 200 sextillion useless stars also contains you, and the fact that it bothered to do both, that it refused to do one without the other, is the most intimate thing anyone has ever said to us across 13 billion years of silence. Close your eyes and imagine the smallest universe that could still contain a human being, one galaxy. Just one, a modest spiral, maybe 50 billion stars instead of 400 billion. A single supermassive black hole at the center, a reasonable amount of dark matter, a few hundred globular clusters, and one quiet arm where a yellow star condenses out of a collapsing nebula. Around that star, one rocky planet at exactly 10, with one large moon to stabilize the axial tilt. Liquid water, plate tectonics, a magnetic field, the whole checklist. Seed it with replicating molecules, wait 4 billion years, and if the dice roll kindly you get fish, then tetrapods, then primates, then a species that invents language, fire, agriculture, telescopes, and eventually looks up and says, "I exist." That universe is already lavish beyond comprehension. One galaxy is already more matter and energy than any pre-20th century mind ever dreamed the entire cosmos contained. One galaxy is already enough to keep poets, priests, and physicists busy for 1,000,000 years. One galaxy is already so improbably fine-tuned that theologians and multiverse advocates have been fighting about it for decades. One galaxy is enough. One galaxy is more than enough. Now open your eyes and remember what we actually got. 2 trillion of them. 2 trillion separate, self-gravitating, star-forming black hole, growing heavy element, cooking islands scattered across a volume so large that the distance from here to the edge is measured in tens of billions of light years. 2 trillion chances for life, 2 trillion experiments in complexity, 2 trillion separate evolutionary histories that will never speak to one another because the expansion of space itself has already sentenced them to eternal isolation. 2 trillion complete ecologies of physics, chemistry, and for all we know biology, most of which will live and die without ever producing a single creature capable of noticing they existed. The universe did not merely overshoot the target. It fired the arrow, burned down the archery range, flooded the continent, and then set the entire planet on fire just to make absolutely, positively, extravagantly sure that somewhere in one overlooked corner the target would still get hit. That is not necessity. That is obsession bordering on madness. Think of every engineering project humans have ever attempted when we really wanted something to work. The Apollo program built 2 of every critical component, sometimes 3. The Large Hadron Collider has backup magnets, backup power supplies, backup vacuum pumps. When surgeons transplant a heart, they keep the patient on full cardiopulmonary bypass until the new organ is beating perfectly. Redundancy is how careful beings behave when failure is not an option. Now scale that instinct up until the beings doing the engineering operate on a canvas of 10 particles and 8 billion years, and you begin to approach the level of cosmic overkill we actually see. The universe did not build 2 copies of the Milky Way, it built 2 trillion copies of everything. It did not hedge its bets, It insured the bets, reinsured the insurance, and then bought Lloyd's of London just to be safe. There is a cold way to read this and a warm way. The cold way is the one most people reach for first. The universe is wasteful, indifferent, almost hostile in its profligacy. It spent 99% of its mass energy budget on places that will never host a single thought, a single kiss, a single song. If the goal was conscious observers, the project is a catastrophe of efficiency. A competent designer would be fired on the spot. But the warm way, the way that actually fits the data, is infinitely stranger. The goal was never efficiency. The goal was certainty. The universe was not willing to gamble the existence of even one mind on the thin thread of a single galaxy. It wanted the phenomenon of someone who can feel wonder. To be so robust, so overdetermined, so embedded in the structure of reality that nothing, no fine-tuning accident, no rogue vacuum decay, no premature collapse, no excessive expansion could possibly snuff it out before it had a chance to wake up and look around. 2 trillion galaxies are not the sign of a careless universe. They are the sign of a universe that was terrified of being lonely. Imagine you are a parent who desperately wants a child, but you know the odds of conception are low. You do not try once, you try every day for years. You adopt every medical advance, every fertility treatment, every superstition that might tilt the probability even a fraction of a percent. You fill the house with cribs you may never need, because the mere possibility that one of them might someday hold a crying baby is worth any price. That is irrational by every accountancy standard, but it is the most human thing in the world. Now imagine you are not a parent, but the laws of physics themselves, and the child you want is not a baby, but the phenomenon of conscious experience. You cannot try again tomorrow, you only get one universe. So you do the only thing you can. You turn every dial to 11, you scatter matter like confetti, you create 2 trillion separate petri dishes and seed every single one with the raw materials. Stars, planets, chemistry, and if the dice roll kindly minds. You do it because the alternative, a sterile cosmos where nothing ever wakes up, is unacceptable. You do it because even one moment of someone, somewhere, looking up and feeling their chest catch is worth burning the entire budget of reality to guarantee. That is what the numbers are actually saying. The universe did not need to be this big to produce Beethoven's Ninth. It did not need 2 trillion galaxies for Dante to write E. Quindi Asimo arriveder l'Estelle. It did not need 200 sextillion stars for a child in Rwanda to laugh so hard she falls over in the dust, or for 2 old women in a Tokyo subway to hold hands without speaking, or for a single astronomer in 1924 to measure the distance to Andromeda and realize, with shaking hands, that the universe is larger than anyone had dreamed. And yet every one of those moments, every tear, every equation, every first kiss is only possible because the universe refused to take the risk of being too small. It overbuilt reality the way a love-struck teenager writes the same name 10,000 times in the margin of a notebook, not because it is necessary, but because the thought of the beloved never existing is unbearable. There is a word in Portuguese, saudade, that means the presence of absence, the feeling of missing something that may never have existed in the first place. The universe, with its obscene immensity, feels like saudade made of mathematics. It is a cosmos that missed us so intensely that it exploded into 2 trillion pieces just to make certain we would not fail to arrive. So when people say the universe is too big, what they usually mean is, I am afraid my life does not matter. But the correct reply is not yes, you are insignificant. The correct reply is no, look how much mattered to the universe that you would show up at all. 2 trillion galaxies are not the price of indifference. They are the price of desperation, the desperate, extravagant, unreasonable insistence that somewhere in the whole vast dark, a light would turn on inside a skull and notice that the dark was beautiful. The universe did not need to be this big. It wanted to be this big. It wanted it so fiercely that it became physics. And here we are, the overinsured, against the redundantly guaranteed, the lottery winners of a jackpot so large that the ticket costs 2 trillion entire galaxies and 13 billion years of patient waiting. Every time you feel small under the night sky, remember that smallness is not the point. The point is that the sky itself is a love letter written in fire, signed with 2 trillion names, and addressed to you. The first time the number 2 trillion galaxies lands on a human mind, the usual reaction is a kind of emotional whiplash. 1 second you are standing on solid ground, a creature of markets, deadlines, heartbreak, coffee, taxes, birthdays, and the next second the ground is gone. You are falling upward into a darkness so crowded with burning cities that darkness itself feels like a lie. The fall is terrifying, exhilarating, and if you let it finish, strangely gentle, because what you hit at the bottom is not despair. You hit gratitude so intense it feels like a second heartbeat. Most people expect the cosmic perspective to be crushing. That is the cliché, the pale blue dot, the mote of dust suspended in a sunbeam, the idea that scale reduces us to nothing. It is half true. The first impact does feel like annihilation. Your ego, accustomed to being the center of at least its own story, suddenly discovers it is a rounding error in a ledger written in light from before Earth existed. That hurts. The mind recoils. It reaches for the usual narcotic comforts: nationalism, consumerism, gossip, sports scores, anything with humans, scale boundaries. For a while you succeed. You close the astronomy book, turn on a sitcom, and pretend the universe is still the size it was in 1920. But the number does not forget you. It waits. It is patient, the way oceans are patient. Eventually you go outside again on a night with no moon. You lie on the grass until the sky peels open, and this time, instead of bracing for the blow, you let the fall happen all the way to the end. You let 2 trillion galaxies pour through the hole where your defenses used to be, and something astonishing happens. You do not disappear. The terror flips polarity and becomes the purest gratitude a primate brain can manufacture. You realize the cliché was exactly backward. The problem was never that we are small. The problem was that we mistook smallness for insignificance. Smallness is just geometry. Insignificance is a judgment. And the universe, with its ridiculous, embarrassing, borderline, pathological excess, has already voted with 200 sextillion suns. You are not insignificant. You are the reason the vote was held in the first place. That is the moment the night sky stops being scenery and becomes a mirror. Look closely at any deep field image Hubble web. It hardly matters. Every smudge, every spiral, every red fleck is a place where gravity once pulled a cloud of gas together until it caught fire. Every one of those places cooked carbon, oxygen, iron, gold. Every one of them could have, for all we know, did host worlds where water learned to dream. And yet, of the countless trillions of possible stories written in those 2 trillion volumes, the only page we can read with certainty is the one written on a moist planet orbiting an average star in an average galaxy. That page contains war, cathedrals, vaccines, genocide, lullabies, concentration camps, space probes, and a teenager somewhere right now kissing someone for the first time while wondering if the universe notices. The universe notices. It notices so hard that it built 2 trillion libraries just to make sure this one book would be written. You are not lost in the crowd. You are the crowd's entire justification. There is an old Zen story. A monk asks the master, "What is the meaning of Buddha's enlightenment?" The master replies, "When I am hungry, I eat. When I am tired, I sleep." The monk protests, "But that is what everyone does." The master smiles. "No, most people, when they eat, do not eat. When they sleep, they do not sleep. The same is true of looking at the sky. Most people, when they look at 2 trillion galaxies, do not look. They see a pretty picture, feel a momentary shiver, then return to the urgent business of being afraid of Monday. But a few, just enough, let the picture keep looking back at them until the boundary between observer and observed dissolves. At that point, the galaxies are no longer out there. They are in here, in the same way the iron in your blood is in here, forged in the same explosions that lit those distant cities billions of years ago. The separation was always an illusion maintained by the convenient thickness of a skull. When the illusion collapses, gratitude arrives uninvited and stays forever. It is not the gratitude of a servant toward a king, it is the gratitude of a note toward the symphony that bothered to include it. The symphony could have been written without that 1/4 note rest on page 347. Technically, it would still be a symphony. But the composer, for reasons that are not technical at all, refused to leave it out. The rest is only silence, but it is a silence that changes everything that comes after it. You are that silence. You are the pause the universe insisted on writing into the score, even though the score was already 2 trillion measures longer than strictly necessary. Once you feel this, the old existential questions stop sounding like accusations and start sounding like love letters. Are we alone? The correct answer is, you are so unfathomably not alone that loneliness itself is revealed as a kind of optical illusion produced by living inside a body. Every atom in you has been part of countless other bodies, stellar cores, nebulae, the hearts of ancient suns, long before it signed up for this brief mammalian internship. Your isolation is a temporary costume you agreed to wear for one lifetime, so the universe could experience what it feels like to forget, briefly, that it is everything. Does my life matter? The universe spent 13.8 billion years and the energy equivalent of 2 trillion galaxies to stage the exact configuration of atoms that would one day look up and ask that question. If that is not mattering, the word has no meaning. Why is there something rather than nothing? Because nothing discovered that it was incapable of experiencing gratitude, and gratitude, it turns out, is worth 2 trillion galaxies and a few billion years of patient waiting. People sometimes worry that this view is sentimental, that it smuggles meaning in through the back door after science kicked it out the front. But sentimentality is cheap emotion attached to small things. This is the opposite, accurate emotion attached to the largest thing we have ever discovered. The numbers are not soft, they are brutal. 2 trillion is not a metaphor. It is the current best estimate from people who spent decades trying to prove it was smaller and failed. The gratitude that follows is not wishful thinking. It is the only psychological state proportionate to the datum. There is a night I remember clearly. I was on a mountain in Chile, outside the dormitories of the Very Large Telescope. The Milky Way was so bright it cast shadows. A friend, an astronomer who had spent years mapping galaxy clusters, stepped outside for air. We stood in silence for a long time. Then, very quietly, he said, "Sometimes I think the universe made all of this just so it could watch itself being watched." He was not drunk. He was not sentimental. He was simply reporting what the numbers had finally forced him to feel. That is what happens when you stay with the fall all the way to the bottom. You discover that the void was never empty. It was holding its breath. So the ultimate takeaway is not that we are small and therefore meaningless. The ultimate takeaway is that we are small and therefore cherished beyond reason. The The universe did not need to be this large to produce one planet with people on it. It wanted to be this large, the way a lover wants to give a gift so extravagant that the beloved will never again doubt they were worth the trouble. Every time you feel crushed by the news, by mortality, by the ordinary brutalities of being human, remember that somewhere in the ledger of reality there is an entry that reads, cost of, guaranteeing that one fragile consciousness would exist long enough to feel pain and still choose kindness, approximately 2 times 10 2 galaxies, 13, 8 times 10 9 years, and one universe willing to look ridiculous for love. That entry has already been paid in full. The stars are not indifferent, they are the receipt. So go outside tonight, find the darkest place you can, lie down, let the sky pour its impossible inventory over you until your ribcage feels too small to contain what is trying to get out. And when the gratitude finally breaks the surface, when the tears come, when the laughter comes, when the only sound you can make is a small cracked thank you that no one will ever hear, know that you are not speaking into a void. You are completing a circuit that began before the first atom formed. You are the universe's way of saying you're welcome, and 2 trillion galaxies were the smallest love letter it could think of that would still fit the feeling.